Okay, so let me just start off by reviewing the rules. These are the 4 new rules that we need to be responsible for. So natural log of u, derivative is just u prime over u. Your u value is whatever is inside your natural log expression. Okay. Log base a of u, so natural log is base e. Base a would be bases other than a or other than e, so like base 2, base 3, base 5. They all will take on u prime over u as well, but there's a little bit of extra adjustment that needs to be made in front. So you still have u prime over u, but if it's base a, base 2, base 3, base 4, we have to include this conversion that has to happen. So 1 over natural log of a. It's just going to be a number or coefficient that's going to sit in front of u prime over u. The derivative for e to the u is just the original function. So the original function is going to appear in your derivative, multiplied by the exponent's derivative. A to the u, very similar to e to the u. It's still the original function's derivative times the exponent's derivative. But there's a little bit of extra here. This is not base e. Base a is going to feel a little bit more expanded. So natural log of a has to sit in front. It's also good to know log properties. So 3 properties that we use a lot. Anytime we see a messy log or natural log expression, we can use product property. Natural log of AB can be expanded into natural log of A plus natural log of B. Natural log of A over B can be expanded into natural log of A minus natural log of B. And finally, if I have natural log of A to the n, that exponent that is sitting in your natural log expression can be nicely moved to the front without changing the overall value. So I think some people or some students have mistaken this for a derivative power rule, but there's no power rule here. Okay, so this is not a derivative rule. This is just expansion rule that will allow your derivative to be easier because your u value will be will not have to have a chain rule involved. Okay, so let's start with number 1 here that I have on this worksheet here. Y is equal to 7 raised to the cube root of 1 minus 2x squared. All right, so now this matches nicely with our a to the u rule.
Mr. Yang, can you hear me?
Question?
Can you hear me?
Yes.
What problem are you doing? Is this
oh, this is off of the. I'm just making this is off the class review that I have on my website, but I also put it in the. I put the link in the chat box.
Okay, thanks.
Yeah. Okay, so we're following along with this rule here. This is the a to the u rule. Let's see. Right. All right, so this matches nicely with a to the u because this is an exponential function. Base 7 raised to the exponent. So my a is 7, my u is this entire expression. But I do want to get that u value a little bit cleaned up. Okay, so this is an exponent that we really can't bring down because this is not a natural log expression. So we're going to jump directly into our derivative rule. We have a rule nicely set up for a to the u. So here's our derivative, y prime equals, just follow along, right? Natural log of a, natural log of 7. Times a to the u. Times u prime. Now u prime is the full derivative of my exponent. And this is going to require a little bit of chain rule here. Right, there's the outside portion and inside portion because of the complexity of my u value. You take turns with each derivative, and all that is going to take the place of u prime, and it'll just sit right here. Okay, so outside derivative, 1/3 parentheses to the negative 2/3. So we keep the inside portion intact while we take the outside derivative. So once we take outside derivative using power rule, we multiply by the inside derivative, so times negative 4x. Okay, so there's not much that we can do with this derivative. It's a little messy, but I can maybe just put the numerators together, put the denominators together, put all under one fraction. So numerator, numerator, numerator. And these are my two denominators. Okay, any questions?
Can you hear me?
Yes.
Where does how do you know to go through the derivative with like the LA and stuff?
How do we know to use this derivative rule?
Yeah.
So this is an exponential function. So exponential function is like a constant raised to a variable. So anything that is a constant raised to a variable is called an exponential function. An exponential function is going to take on this a to the u rule.
Okay, so when you're trying to find the derivative of an exponential function, that's when you're going to do that rule?
That's right. That's right.
Okay.
There's another exponential function, and that other exponential function is e to the u. Okay, so if it's base e to the u, then we use the specific rule. But if it's an exponential function that has another base besides e, like base 2 or base 3 or base 5 or base 10, then we use this a to the u rule that handles all the other bases for exponential functions.
And when we're talking about an exponential function, the base is like, in this case, 7?
Yeah, that's right. So here are some other examples of exponential functions.
Okay.
So 2 to the 3 minus 4x, or 5 to the x, or 6 to the square root of 1 minus 6x squared, or 8 to the x, right? These are all exponential functions. But these all use the same derivative rule because these are all exponential functions of bases other than e. Right, so for all these functions, we use this rule. But for anything that starts with base e, like this, then we use the rule for e to the u.
Okay, can I copy that
Okay, does that make sense?
Yes, thank you.
Good. All right. Any other questions with one? Okay, here's number 2. Okay, so next problem here. I want to find the derivative of this expression. Hopefully we can see that these are actually 2 expressions with a multiplication sign in between. So we have to apply product rule. Once we're inside product rule, then we can handle each individual rule. This first one is power rule, and this second one is log base A derivative rule. Okay, so this is my f and g function here. I know eventually I'm going to have to use my derivative rule for log base A. But we know that with a log expression, we can always expand out a little bit more before we get ready for power derivative, right? Anytime we have a log expression, we have a power property that we can apply. So let me rewrite this problem here before I jump to my derivative. And also, if there's no base showing, there's a hidden base, and that base is going to be base 10. Okay, so I'm just rewriting this radical as a rational exponent. And now if I look at this expression here, before I even find the derivative of this expression, this 1/4 can come down in front, which will allow my u value to be a lot cleaner than if I just let that 1/4 sit there. So I'm just taking my time to rewrite my problem so that when I get to my derivative, I won't have to do, I can just jump directly into my derivative rule. So now my f and g will feel a little cleaner because I can go directly into my derivative rule once I start my product rule process. Okay. Any questions so far? So we haven't changed anything yet. We've just made it so that our derivative steps will feel a little more efficient because we've done the work of getting that second term ready for this rule. Any questions with number 2 so far?
Mr. Yang,
Yes.
your screen's frozen.
Oh, it is? It looks fine to me. Are others of you feeling that same way as well?
I don't think it's frozen. I think you just haven't started the rest of it, maybe. I don't know.
Okay, it just unfroze.
Oh,
Okay, how about now?
Better.
Okay, so take a look at what I have so far. I've done, I know I got to do product rule. I know that that second term needs to be cleaned up a little bit. So I did some cleanup. I got that base showing. I brought that exponent down in front so that both terms are ready for my derivative process here. Okay, so product rule here, f prime g plus fg prime. Okay, so f prime is just going to be a pretty straightforward power rule here. X to the fourth times 4x cubed. We keep that g function the same. Back to f. And then g prime. Okay, so we're going to apply this rule here, log base a of u. The 1/4 is just going to hang out in front. Log base 10, that's log base a. It's going to turn into 1 over natural log of 10. And then u prime over u is for my parentheses here. So my derivative of my parentheses, the 1 goes to 0. Negative 5x cubed becomes negative 15x squared. Okay, we can do a little bit of cleanup. Yes, question?
How do you get the G prime again?
That g prime came from this expression here, right? So my 1/4 is going to stay. Log base 10, that's my log base a. It'll be 1 over natural log of a, so 1 over natural log of 10. And then my u value is 1 minus 5x cubed, so negative 15x squared over 1 minus 5x cubed. So I'm just following whatever my rule says, matching the parts with my derivative rule and applying my derivative rule.
Okay.
Okay, so in terms of cleanup here, we can do a little bit of cleanup within each fraction. Well, within each term here. So I'm going to put some of these together here, and then separately I'll put some of this together and just have two fractions, okay, or two separate terms here. So the 4 and 4 can reduce. 4 and 4 cancels out. Here I can put the x to the 4th with a numerator, so make it negative 15x to the 6th. The 4, the natural log of 10, and 1 minus 5x cubed can all just share the denominator space. Okay, any questions with 2? All right, let's look at number 3. Okay, so I have a natural log expression here. Looks like there's something that we can expand before we jump into our derivative rule. I can expand further. I can bring that exponent down. I'm gonna get that second term ready first though. Get that radical to be converted. Right. Pull the 3 1/2 down using power property. And this is all just cleanup. Okay, there's no calculus here. We're just expanding it to the point so that our derivative feel easier. So now that we have this expanded all the way out, now we can apply our derivative rule, which is u prime over u. Okay, the u value is just whatever you see inside the parentheses. And coefficient is going to hang out in front. U prime, derivative of phi minus x, will go in the numerator of my expression. One half stays. 2 plus 3x to the fourth becomes 12x cubed over the entire parentheses. So now we're just going to clean this. We'll just put let's clean up the fractions a little bit. You can reduce the 12 and 2 here. Okay, any questions with 3? Okay, all right, let me see if I can create some more problems for us here. Let's call this number 4. Okay, so this one, couple of rules as well as product rule, right? We have 2 separate terms here. So let me list out everything we got to involve here. We also have to involve e to the u rule once we're inside product rule. So these are both exponential functions, but this is base e, this is base 3. So we also need to involve a to the u rule. All right, let me set up using product rule here, y prime equals. Okay, so f prime I gotta take care of e to the 3x derivative. So I go to my rule here, e to the u times u prime, so e to the 3x times 3. All right, g function, no changes. All right, back to f. Okay, g prime, I need to find the derivative of this exponential function. This is a to the u. I do want to get my u value a little bit cleaned up so that I can see the chain rule that's going to be involved here. So let me rewrite this. This is really 3 to the 5 minus 4e to the x to the 1/2. Okay, so I'm going to step through my rule here. This is my a value is 3. My u value is this entire exponent. So I'm going to start my rule here, natural log of a, so natural log of 3. Times the original function. Times u prime. Now, if my u value is this full parentheses, and this parentheses has stuff inside and outside, so for my u prime, I got to go through chain rule because of the complexity of my exponent. So outside's derivative, 1/2 parentheses to the negative 1/2. Multiplied by my inside's derivative, that's my outside's derivative, right? 1/2 parentheses to the negative 1/2. My inside's derivative, 5 goes away, 4e to the x just becomes e to the x times 1. So just negative 4e to the x.
Mr. Yang?
Yeah.
So when you're doing chain rule for this part,
Yeah.
can you explain how to take the derivative of the inside? How do you get that?
Right. So the derivative of 5 is 0. And the derivative of e to the x is just this rule here. So the derivative of e to the x is just e to the x times 1. And the 4 just tags along for the ride. So the nice thing about e to the x is that the derivative of this function is the function itself.
I don't understand. So you defy this out of the question because it's you do them separately when you're taking derivative? Right.
You see that minus sign there? That minus sign allows me to take my derivative separately of each term. So what's the derivative of 5?
Okay, so that's just 0.
0, right? And the derivative of 4e to the x is just 4e to the x times 1. The 4 is a coefficient, so it just hangs out in front. The e to the x is really what we're talking, we need to make a derivative for. So the derivative of e to the x is just e to the x times 1. But that
Where
one
do you get the 1?
Sorry?
Where do you get the 1?
Because I'm applying my rule here, e to the u equals e to the u times u prime. So if my u is my x, then the derivative of e to the x is just e to the x times x's derivative, which is 1.
Okay, got it.
Which really makes it look like as if nothing has changed, right? And that's the nice thing about e to the x is that they call this the easiest derivative rule because really you can just copy the exact same problem down and you call it the derivative. All right, so this is still a messy problem here. Maybe I can do a little bit of cleanup. Try to push some things together. All right, so I have a lot of pieces here. Maybe I can kind of push all this into one fraction. So let's see here. I got the negative 4e to the x with the e to the 3x and the natural log of 3 and the 3 to the square root can all go to the numerator. And my denominator will be the 2. And then the square and the negative exponent pushed down to the denominator of that parentheses. Okay, questions there? Okay, I can continue to just come up with some example problems. But do you guys have any specific questions that you guys have?
Could you repeat that?
I can just continue to make problems up for us to practice, but I wanted to see if you guys have any specific questions you guys have. Make sure you get those answered.
Could you just do another problem with like the e's?
Mm-hmm. Like something involving this here, like that.
Yeah.
Mr. Yang.
Yes.
So the quiz will be over basically these 4 topics.
Yep. Yep.
These 4. So we'll have those 4 type of problems, and then with like the ln, and then also there'll be one or something like where we have to do that ln AB and then make it
Yeah.
ln A plus ln B.
Yeah, exactly. Right. So here's the morning review that I'll go over tomorrow. Right. We need to be comfortable with expanding if we see the need for it. We need to be able to apply the derivative rules for each of them, either by themselves or in conjunction with another type of problem, which then we got to do product rule. Right. So yeah, so we have to be able to expand not only natural log, but also, logs of other bases, take care of all those expansions, but then also be able to apply each of the derivative rules if they're either standalone or within a product rule. Right. So if you get a chance to work through the morning review, I think that'll be good. That way, tomorrow when we go over it, you'll have, specific questions, because if you're stuck on something, you can arrive at it on your own before the morning review. So that's what I suggest.
Okay, thank you.
Mm-hmm. Okay, so this number 5, I just created this problem here, e to the 6 minus 4x to the 5th power. This is a standalone term here. This is not, there's no product rule here. So we can jump directly into our e to the u rule. I'm just going to follow the rule here. The rule says e to the u times u prime. So u prime is really where the work is going to be had because I got to go through the derivative of that full exponent, which is chain rule, right? This is a little messy here. So y prime equals e to the u. That's my derivative. So just copy the exact same problem down. Times the exponent's derivative. So exponent's derivative, that full expression, I got to go through chain rule. There's an outside and inside portion I have to involve. And all that is going to have to be part of my u prime. Okay, so outside derivative is parentheses derivative is 5 parentheses to the 4th power. Multiplied by the inside's derivative. 6 goes to 0, negative 4 becomes negative 4. Okay, Maddie, good so far?
Yeah.
Yeah, so that's basically it. We can do a little bit of cleanup. Just maybe putting the 5 and negative 4 together, but there's not much we can do beyond that. Okay, everyone good so far? Okay, so number 6 is log base 7. It's not natural log, but it's still log. So we can take advantage of all the expansion properties that we had for natural log. So I'm going to take care of that 5. I'm going to take care of the individual
Yang.
numerator denominator. Yes.
Say you wrote the answer to number 5 as negative 20 times 6 minus 4x to the 4th times e to the whatever. Is that okay too?
Yes. Yeah. With multiplication, you can rearrange them any way you want
Just
to.
so it's okay if I had the negative 20 in front of the 6 minus 4x
Yes.
and
Yeah, that's
the
perfectly
e off.
fine. Yeah.
Okay.
That's right. Yeah. Typically, though, any coefficient we typically have in front, that's how, if it was
Put
like
it
a
in the
multiple,
front.
if it was like a multiple choice question on the AP exam, that's how they would write it. They would push the coefficient out in front. But these,
Yeah.
it's kind of just whatever. It doesn't matter.
Okay. Thank you.
All right, look at number 6 here. We can definitely don't want to do our derivative just yet, especially if we have these nice expansion properties. So I'll bring the 5 down first. And then within my log expression, I can expand this, right? Log of a over b equals log of a minus log of b. That 5 will just tag along to both terms. This term looks set up and ready. We have our u value that's nice and clean, but this u value, we would rewrite it raised to the 1/2 and also bring that 1/2 down. So We can do some more cleanup here before we do our derivative rule. Okay, push those exponents down in front. Okay, so now we have a derivative rule built for these, which is the derivative of log base a of u is u prime over u, but with a little bit of extra in front. Okay, so we jump into our rule here. The coefficient stays. Log base 7 converts to be 1 over natural log of 7. And u prime over u, negative 3 over 1 minus 3x. Minus 5/2. I can push these coefficients together here. Log base 7, again, go through a conversion. And then u prime over u. Yeah, I'm just going to do a little bit of cleanup here, just within each fraction, just make it look a little cleaner, but I mean, this is fine. The 5 and the 18 and 2 can combine. I'm just going to make the 18 and 2 reduce to be negative 9. Negative 9 times 5 is negative 45. Oh, there's two negatives here, so positive 45. X.
Did you say we could leave it as the one above it, or
That's
do you
fine,
want
yeah.
us to?
That's
So
fine.
that's fine if we just leave it like that.
Yeah.
Okay.
Okay, I got one more for us, and then if you have any questions, we can go over any of those. Any you have? Okay, so here we definitely see product rule. We see the a to the u rule, and we also see the log base a rule. I know I got to do product rule, but I'm going to do some cleanup here, get this nice and ready so that I can jump directly into these rules. Take care of all my expansions that I can take care of here. there's a hidden base. That hidden base is 10. Continue to do some cleanup here. All right, I've cleaned up my expression as much as I can. Now I can jump into my product rule here.
Create.
Yeah.
So you don't want to take the derivative before product rule. You have to do product rule first.
That's right. That's right. Because if we just find a derivative by itself, then we're doing things out of order, right? We have to kind of lay out our product rule pieces first so that we can take each derivative, where they belong. Right? Because if I just find a derivative of this,
Got it.
then I'm really disregarding the fact that there's a thing that's attached to this expression. So think of product rule as your kind of as your structure for how your derivative is going to look. Yeah, lay out your structure, and then you can find the derivative when you're called to do it for that term. So f prime, 5 to the 4x, natural log of a, times a to the u times u prime, so natural log of 5, times 5 to the 4x times 4. Back to f. Okay, g prime. Gotta use my log base a rule, so the 1/2 is just hanging out in front. 1 over natural log of 10. U prime over u. So the derivative of my parentheses, the 9 goes to 0, the negative x to the 1/3 becomes negative 1/3 x to the negative 2/3. I forgot about the 2 here. All right, hope that helps.
Mr. Yang,
Yeah.
what happened to the numerator on the G prime?
Oh,
Right there.
You see that negative 1/3 there? I pushed that 3 to this denominator space, and I also pushed that x to the 2/3 down here.
Okay. Oh, so that's how you got 3.
3x, yeah, yeah,
And that's how it
Negative
changed to a
1/3.
negative.
yeah. And I can do that because there's no addition subtraction up here, so I can move this down here. And that is okay.
Okay.
Okay, thank you.
Yeah, hopefully you guys
thank
get a
you.
chance to work through that morning quiz review. I think that'll kind of give you extra confidence, and then you also have specific questions, if you come to the morning review, having already gone through that already.
Okay,
All right,
thank
thanks,
you so much.
guys.
Bye-bye.
See you. Yeah, see you
Thank you.
tomorrow. Bye. Thanks.